Hi everyone, my name is Dr. Vile. Welcome to my YouTube channel, where the purpose of this channel is to help you prepare for your A-level chemistry exams. In this short video, we're going to be looking at how you can determine the formulae of a hydrate. So we need to clarify firstly what we mean by a hydrate. Certain chemicals can absorb water into their chemical structure. So for instance, copper sulfate is a white solid, but if you add water to it, it becomes blue because it incorporates the water molecules into its structure. And what we're interested in here is how many water molecules are present relative to one molecule of the compound. And this becomes quite a typical exam question. I'm just going to take you through two examples how we do this. So here we've got a question about magnesium carbonate. And it says a 15.67 gram sample of a hydrate of magnesium carbonate was heated without decomposing the carbonate to drive off the water. The mass was reduced to 7.58 grams. What is the formula of the hydrate? Well, magnesium carbonate has the formula MgCO3. And then when it forms the hydrate, that means it bonds to water. So we'd say .x H2O. And what we're interested in is for every 1 mole of the magnesium carbonate, how many moles of water are there? And I'll talk you through how to do it. So 15.67 grams is the mass of the hydrate, including the water. And then it's heated, and you're left with 7.58 grams. That means that there are 7.58 grams of MgCO3 without the water. And the difference between these two values must be the amount of water that was lost from the structure. So it's 15.67 minus 7.58 leaves you with 8.09 grams of H2O. And then what we do at this stage is divide each of these numbers by their molecular mass. So for magnesium carbonate, we divide by 84.3. And for water, we divide by 18.02. And that gives me 0.0899. And for the water, that gives me 0.4489. And to work out the value of x, you take the moles of the water, which is this one, the bigger number, and divide by the smaller number. And if you can appreciate that as 0.09 and this is 0.45, this is going to go into it 5 times and x equals 5. So it's just the bigger number divided by the smaller number, which gives me a value of 5. Let's have a look at another example. Here you've got a hydrate of sodium carbonate, which has a mass of 4.31 grams before heating. After heating, the mass of the anhydrous compound, so without the water, is 3.22 grams. Determine the formula of the hydrate. So we have 3.22 grams of Na2CO3, which is the sodium carbonate. And the difference between these two values must tell me how much water was lost. So you've got 1.09 grams of H2O. So as before, we're going to divide these numbers by their atomic mass. So you divide, or molecular mass in this case. So that would be divide by 106, and divide by 18.02 for the water. So that's 0.0304 for the sodium carbonate, and for the water it's 0.0605. And just at a glance at these numbers, can you see that the number for the moles of the water is twice that of the sodium carbonate, and therefore our formulae must be Na2CO3 .2 H2O. So for every 1 mole of this, divide them both by the smallest number, you'd get a ratio of 1 to 2. So therefore there are 2 moles of water for every 1 mole of sodium carbonate. Well, I hope that was helpful. If you like this video, please like it, please share it with your friends, please subscribe to the YouTube channel, and I will see you next time.